Hello, guys, and welcome to our class for today. Today we're treating a very important topic, and one of the largest topic we'll be ever treating, which is hypothesis testing. It's a very important topic in statistics, and there are several branches to it. We're going to try as much as possible to exhaust the much that we can, and I will refer you to where you can complete the rest. So let's get started quickly with hypothesis testing. Now, what's hypothesis testing? Hypothesis testing is a process of reasoning about data. We have to decide if our data are ordinary or extraordinary. Now, hypothesis testing is a process of testing whether a group of data sets, whether there is something extraordinary about them or whether it's just a normal ideal thing that we're supposed to expect. Now, most of the research out there follow this pattern. You're actually trying to test whether there is something unique or something special or something out of the ordinary. So what's null hypothesis? So we are checking between our null and alternative hypothesis. So what exactly is our null hypothesis? Observe represents nothing new or out of the ordinary. Now that is the norm of what is expected. Then our alternative hypothesis is that observe represents something new and important. For instance, if you want to test whether the people in Chinese are shorter than average, now that our null hypothesis is going to be that their height is the normal height of what is obtainable anywhere, then the fact that they are shorter is going to be our alternative hypothesis, and it's fine. You can create as many examples as you can for several scenarios. Okay, the aim is rejecting or not rejecting the null hypothesis, that is not accepting the null hypothesis. So generally the null hypothesis is what is easier for everybody to believe. Then you are trying to prove whether you should reject the null hypothesis or you should accept the null hypothesis. So the types of hypothesis testing. Remember I mentioned that hypothesis testing is a very broad subject or very broad area. We have different types. We have mean hypothesis testing, we have ANOVA, and we have variance hypothesis testing. Okay, under mean hypothesis testing we have two sample independent tests, paired sample test and one sample test. Now I'm going to take time to explain when to apply each of them. Is that okay? As I said, I'm compacting all what we did for years in just this 8 weeks. So I'll need you to pay very good attention, and I'll need you to, if possible, review these videos over and over again to make sure that you are not missing anything. Now the first one under mean hypothesis testing is two sample independent t-test. Now how does this one work? This one is when you want to compare the mean of two independent samples. For instance, maybe you want to check you want to find out if the mean of the height of people in Nigeria is different from the mean of people in Ghana. So in that kind of case, there are two independent samples. Is that okay? And so you could use that, or maybe the test score of boys and the test score of girls in a class, whether there is boys perform better than girls. I'm sure boys perform better than girls. All right. So that is what you might be trying to test. That's on a lighter mode. But in that kind of situation, what do we do? Now we have paired sample test. In that kind of situation, we use two sample independent because the sample for one set is totally different from the sample of the other test. And then we have paired sample t-test. In paired sample t-test, that one you're using the same data test set. Maybe you want to do most of this experiment like pre and post. For instance, maybe before an intervention program, you took a test, and after the intervention program, you took another test. The same people now that took the first test are the same people that took the second test. Or let me say you give a test by 2 o'clock and you give another. There's a belief that maths is better understood in the morning. So you now give one in the morning and give one in the afternoon to compare the same population. So in that case, you use paired sample t-test. The one sample t-test is when you want to compare a sample, one sample with a definite value. For instance, you believe that the general height of the general test score for males in a class is, let me say, 55. So now when a new set comes, you want to check that class with that 55. So in this case, we are testing one sample with a fixed value, no longer two samples like in the former two cases. Don't worry, I'll still spend time to explain what I mean by all this using practical examples. Then we have our ANOVA, one-way repeated measure and two-way ANOVA, variance hypothesis testing, and other variance hypothesis testing. We have chi-square and f-test. Let me just leave them there for now, and I promise we'll still go back to them, every one of them, and explain something. But if you notice, I highlighted some things here, which is z-test and t-test. Now each of these mean hypothesis testing, these are for mean hypothesis testing. Each of them can either be a z-test or a t-test, although mostly they come as what? T-test. Mostly they come as t-test. But they can also be what? Z-test. They can also be z-test. I'm going to show you when to use t-test and when to use z-test for them. Another thing I put here to note is that for dependent sample, Wilson single rank test. Okay, for cases where we are not dealing with ordinal data, we are using with ranked data, we can use this. If it doesn't satisfy the condition for hypothesis testing, we can use this for dependent, and we can use this when it doesn't satisfy the condition of equal variance. For those of us who are into statistics, you might understand what I mean here. There are some assumptions you need to test for before you can apply some of all this analysis. But if it doesn't meet those assumptions, the one of equal variance, you can apply this, and if it meets it, fine. If you don't understand what I'm saying, don't bother yourself. These are just very rare cases, but I just felt I should mention it for those who will be needing an extra. But if you don't get it or you don't grasp what I'm saying, you are still very, very well good to go. Alright, so when to use z-test and when to use t-test. Do you know the population standard deviation? Now, if you know the population standard deviation, then you can, if you know it, then you can, if you don't know it, automatically you are using a z-test. But if you know it, you still have one condition again. Is the sample size above 30? If it's above 30, you are using a z-test. If it's not above 30, you are using a t-test. I'm going to change all this into PDFs, and I'm going to send it into the group, so you can always make reference to them when you need to. Alright, so what's the process of hypothesis testing? Now, each of them, whether ANOVA, whether mean hypothesis testing, or whether variance hypothesis testing, they all follow these these three basic steps. The first one is formulate your null and alternative hypothesis and decide on your alpha. Remember, we mentioned this alpha during regression, right? And what did I say the alpha is? If you can remind me, I said, if you can remember rather, I said the alpha is our probability that our experiment is correct or analysis is correct or not. And I told you that statistically the norm, or the what do they call it, the default value is 0.05. That means every statistic, the default is that they want to be 95% sure. So, but there are cases maybe in medicine when they require 99 or something higher, because we are bringing a new drug. They need to be very, very sure that it doesn't harm anybody. And then there are some other cases that you could see 90 or even 87 or so, but by default it's 95, which 95%, which gives us an alpha of 0.05. Is that okay? So after you have done that, you need to generate your null and alternative hypothesis. Very important. Your null hypothesis, remember, is the normal thing that is expected, and your alternative hypothesis is what you are trying to prove, or what you are suspecting is out of the norm but is true. Now the next thing is to gather your data. Now after that, you now gather your data, right? Gather the data. For instance, if it's you are suspecting that, oh, in this school ladies are actually far more intelligent than the guys, so you generate your null hypothesis. Ladies and guys are both equal in their IQ. Then you now say, okay, ladies are more intelligent that's your alternative. Then you gather your data, you begin to get student scores, then you convert it to a scale of the appropriate distribution. I'm going to explain more of this, so if you don't get what I'm doing now, we're going to do practical examples and you're going to understand what I mean by this. Then after you have done that, then the next is to decide whether or not to reject the null hypothesis if the converted statistics is in the rejection, if it's in the rejection region. Yes, there's supposed to be a region. There's supposed to be a region here. Region. Then from there you now reject H0. Region, and then region, comma, then reject H0. So if the converted statistics is in the rejection region, then you reject H0. Now after that, you now decide whether you should pick your null or your alternative hypothesis. Is that okay? So that is the last step. It's not too difficult, please. I just sense that some people might be entirely new to this and might just find this as gibberish, but please just stay through with me, please. It's going to make sense sooner or later. Now, mean hypothesis testing. Now let's focus on the mean hypothesis testing. Another mean hypothesis testing, I'm going to be looking on one sample mean test. Remember, this is the third one I gave as example, but for whatever reason, I'm just making it the first one we'll be treating. One sample test of means compares the means of a sample to a pre-specified value of a deviation from that. One sample test of means compares the means of a sample to a pre-specified value and test for a deviation from that value. Now, that's what I mentioned earlier. In this case, one sample t-test, there is a pre-specified value. Then you want to compare the mean of a sample to that pre-specified value. And there are three tests we can perform. The sample is greater than the specified mean. We can want to check whether the sample is greater than the specified mean. The sample is less than the specified mean. You might want to check if the sample is less than the specified mean, or the sample is not equal to the specified mean. Now, the first one is greater, less than is less than, but this one you are not sure whether it's greater than or less than, but all you are just testing is that it's not equal to this value. Is that okay? So those are the three scenarios you can have. These are first scenario, greater than; second scenario, less than; and third scenario, not equal to. Then we can test. Note that each test has a different hypothesis but the same approach. Now each of them follow the same approach, but they just have different hypotheses, which I'm going to show you guys. But I hope you are beginning to understand the process of hypothesis testing. Is becoming easier and better for you to understand. I hope so. So if you are with me, please give this video a like if need be, and subscribe to our channel. And let me hear your comments. You can always drop your feedback with us, either in the group or even in the video there directly. And continue. So hypothesis testing, example 1. Now let's look at a practical example. This is going to help you to understand what we're doing. A social scientist believes that certain persons in a region have an higher than average IQ. Now there's a social scientist that believes that persons in this region, their IQ is higher than average. Let's say Lagos, for instance. People in Lagos, they are streetwise, their IQ is higher than normal. So that's what he believes. So now the average IQ is 100%. Is 100. So now the guy is saying that our H0 is that their IQ is 100 or even less than 100. That is a normal thing that's obtainable in everywhere. Now the null hypothesis which he wants to test for is that it's greater than 100. Now in this case, check, in this case is a one sample t-test because we are comparing a specified value to a sample. So there's a sample which is that region, let's say for instance Lagos, and then a specified IQ value which is 100. I keep emphasizing it. The statistics in every analysis or in every research or in every work you get, the main thing you should focus on is which analysis do I use. If you can crack that, then you are 40% or 50% good to go. So in this case, we are going to be using a one sampled t-test. Now look at this other example. A social scientist believes that certain persons in a region, their IQ differ from average. Now in this case, in the first case, he believes that it's greater than, but in this case, he's just saying that I don't know whether it's greater than or less than. But all I know is that it's not the normal one. So average IQ is 100. So are you seeing? In that last case, it was less than or equals to. In this case, our null hypothesis that it just equals to 100, and our alternative is that it's not equals to 100. All right, let's quickly continue. So how do we do it? Now for a z-test, the first thing we're going to do is that if it's a z-test, remember the condition. If it meets the condition for a z-test, you are going to first of all transform value into a distribution with mu0 and sigma 1. This sigma stands for standard deviation. The transform value is the test statistics. The formula for conversion is this. This is the formula for z. Then locate z in the distribution, in the standard normal distribution. If the z score is in the rejection region, reject. If not, don't reject. Now this is how the graph looks like. Okay, the normal graph, and then by the time you convert it, whatever value you get, you're going to check if it's in the rejection region for your alpha. If alpha is equal to 0.05, the rejection region is going to be 1.64. Now you're going to test if it's in the rejection region. If it's here, you reject. If it's somewhere here, you don't reject. Now this is the practical and this is the theory behind it. Is that okay? I'm just trying to give you an idea of the theory behind it, so that by the time we start using software, you don't need to do all this when it comes to software. But I'm just trying to give you an idea. So by the time you talk, maybe you are explaining it before a panel, or maybe you're a freelancer, you are working, or maybe you got a contract with an NGO or something. If you are explaining it to them, you can have more light to what we're doing. I understand, so that you could have a bit of structure in what you are saying. So that's what I mean. So this is just what there is to it. Let's go to the next one. Now if it's a t-test, it follows the same thing. You create a t-test distribution of n-1. This is the formula for t-test. Now you locate your t-score. If the t-score is in a rejection region, you reject. If not, do not reject. If you are solving it with your pen, this is what you are going to do. But we are still going to use our softwares to solve them. Now let's look at a practical example. Now a social scientist believes that people in Lagos City have an higher than average IQ. Now I want to test if his claim is true or not. Now remember, the first thing we said is that what measure IQ of 256 people from Lagos City. Now he cannot measure the IQ of everybody in Lagos State, but he measures the IQ of 256 people in Lagos State, and he found their mean to be 102.5. Now remember his statistics, because he's 102.5, you don't say it's above average, therefore people in Lagos. No, we don't do that in statistics. What we do is that you first of all need to settle down and check if that difference is statistically significant. Is that okay? So the big question is the claim true? Now look at our hypothesis. Remember, it's less than or equals to 100, and each one is that it's greater than 100. This is supposed to be mu, because this is average. Sorry about that. This is supposed to be mu, the u of the Greek letter. That's what we mean by mu. So the measured IQ of this is 256. The average IQ is 102.5. Our alpha is 0.05, and our critical value is 1.65. So remember our formula for z, which is bar x minus mu all over 16 over 256. Now they have given us so this is our x, this is our 100, and remember, if you look at if you go back to the video, you're going to see the formula I used there. Remember, our z was equals to bar x minus mu all over sigma. So that is just what we have here. So now look at our z-score. Our z-cal is greater than z-tab. That means if you draw that graph that looks like this, and we have our tab here, our z-cal that is our calculated, is greater than our tab. So we reject the null hypothesis. So therefore we reject the null hypothesis. So the conclusion from this experiment is that people in Lagos have a higher IQ than average. So this thing has proven that people in Lagos have an higher IQ than average. So you can say it boldly now because you have checked it statistically and it is significant. Hope we are making sense. Let's look at another example. Now this is a case for t-test. This t-test, a software designer has created a new user interface for his company. This is a UI UX designer, and he predicts that a user will make a fewer than 10 errors in test of usability. Now he predicts that a user will make less than 10 errors. That means he created a new interface and he's like, see, this interface is so easy to use. That is the success of a UI UX designer, and somebody will not make too much errors. If you want to do something, it can be intuitive. The person can intuitively know that, okay, I want to change the brightness. Okay, it should be somewhere around the settings or something like that. I don't know if you get me. So and he's making this thing that, see, if you use this thing, you're going to make a fewer than 10 errors on your first use of the software. I've seen some software that are very, very difficult to use. You open them, you'll be like, wow, where do I even start from? But the guy is saying that, see, you won't make up to 10 errors and you start using it. You don't need any tutorial or guide or whatsoever. So let's see if his claim is true. Now, what's going to be our null hypothesis? I want you to think about it before you look at what I'm going to say. What do you think is going to be the null hypothesis in this case? The null hypothesis case is what's expected. It's expected that if you're using a software for the first time, you're going to make more than 10 errors. So it's expected that our mu is going to be greater than 10 or equals to 10. But what he's trying to prove is that it's less than what? 10. So now that is our step 1. Remember, then the step 2 is to do what? Formulate, gather our data and get our t-statistics to check our steps. So let's gather our data. So monitor and measure the error of 16 users. So they actually got 16 users and we're monitoring how many errors they made before they got comfortable with the software. So they got 16 users. That's why we're using a t-test. It's not up to 30. And then the average errors they made was 8.8 and their standard deviation was 3. So now the critical value is this. So remember, this is our formula for t. 8.8 minus 10, 3 divided by 16, and we got our t cal to be what? Minus 1.6. So in this case, we are concluding that our t cal, which is this, is greater than our t tab, which is this. So it is not in the rejection region. We do not reject the null hypothesis. So in this case, the guy has not proven to us, sorry for this conclusion is wrong. So the guy has not proven to us that his software is actually, you would make less than 10 errors because our t cal is greater than our t tab. Our t cal, which is this, is greater than our t tab. So we do not reject the null hypothesis. So our null hypothesis still stands, that the error the users will make will be more than 10. Our video is getting long, so I'm going to stop here for now, and in our next video I'm going to show us how to practically solve our one sample t-test. So see you in the next video, and bye for now.